skill that we're focused on in this lesson is trying to solve for an indicated variable in an equation. So our goal is going to be to say what operations are currently happening to this variable and how can we undo them. In number 1, it tells us that E equals mc squared, and they want us to solve for the letter m. When I go to identify where m is in the problem, m is currently on the right side, and it's being multiplied by the term c squared. In order to undo multiplication, we need to do division. So if m is currently being multiplied by c squared, the way to get m by itself is dividing by c squared. What that does on the right-hand side is the c squared on top and the c squared on bottom go away and just leave me with m. On the left-hand side, I'm left with e being divided by c squared. I can't do anything more to it, so I have to stop there and say m equals e over c squared. For problem 2, we're asked to solve d equals 2r for r. Again, I begin by looking for the variable I'm trying to solve for and saying what mathematical operations are happening to that variable. Here's the r. What's currently happening to the r is it has a 2 in front of it, which means it's being multiplied by 2. The way I undo multiplication is with division. So if the r is being multiplied by 2, I'm going to divide each side by 2. As always, whatever I do to one side of the equal sign, I have to do to the other side of the equal sign. I did to the right side 2 divided by 2 to make it just have an r left. D and 2 aren't like terms. There's nothing I can really do to reduce that. They don't share a common factor. So all I'm left with, if I read it left to right, would be d over 2 equals r. Basically, we're allowed by the reflexive property to say that either side of an equal sign we can put in either position. So I like to rewrite it where the variable is alone on the left side. So I would rewrite this r equals d over 2, which is mathematically equivalent to d over 2 equals r. For problem 3, we're asked to solve for r. We get the equation p equals r minus c. If I'm trying to solve for r, I first identify it here. I say what's happening to it. Well, nothing's being multiplied by it, but we're subtracting a c from it. The opposite of subtraction is addition. So to get rid of this c that's being subtracted, I'm going to add c to each side. On this side, a minus c and a plus c will undo each other. I'll just be left with this r that I was trying to solve for. It equals p plus c. If those were like terms, we would combine them. P plus c are not like terms, so we just need to leave it as p plus c. When we go to solve p equals mv for m, again, we identify where the m is, say what's happening to it. Well, mv, since they're written next to each other without another sign, means they're being multiplied. To undo multiplication, we do division. So I'm going to divide this side by the v, divide this side by v. The v's will go away and just leave me with m. On this side, I'm left with p divided by v. This one's a little tricky, particularly this 1/2. If I want to solve e equals 1/2 mv squared for m, really I need to understand that this m is being multiplied by 1/2 and also being multiplied by v squared. So I could see this as 1/2 times v squared times m. Still all equal to e. To undo this 1/2, whenever you have a fraction that you want to move to the other side, you're technically multiplying by the reciprocal or multiplying by it over itself, where I flip what was on bottom, put it on top, what was on top, put it on bottom. So really the way to undo this fraction 1/2 is to multiply by 2 over 1. When I do that to this side, 2 over 1 is really just multiplying by 2. So then I have to multiply the left side by 2 as well. To get rid of this v squared that's being multiplied, I need to divide by v squared. So here, these will get rid of each other. Here, these will get rid of each other, and I'm just left with an m. Since I divided this side by v squared, I also need to divide this side by v squared. That means I'm left with m equals 2 times e divided by v squared. 2e divided by v squared. This is among the trickiest ones that are asked in this lesson. Again, there's different ways to look at this 1/2. Really, if you said, I'm going to divide by 1/2 since it's being multiplied, dividing by 1/2 is the same thing as multiplying by 2. So it would get you to the same answer, but I'm guessing it might be a little tricky to see how you get there. I'm trying to show it as multiplying by the reciprocal, so I'm hoping that makes it a little easier. But I understand anytime fractions enter a problem, it gets confusing for students. For problem 6, I'm asked to solve for t. The equation is h equals vt minus 16. To solve for t, I see that it's currently being multiplied by v, and then 16 is being subtracted from it after that. The first thing I want to move is this 16. Since it's minus 16 on this side, if I add 16 to each side, negative 16 and positive 16 are opposite operations and will go away. On this side, I'll have h plus 16 equals, I still have the vt here, but I no longer have the 16. Whenever you have addition or subtraction outside of things that are being multiplied, you want to do the addition or subtraction first before you deal with what's being multiplied. Because really, by order of operations, this multiplication takes precedence and this subtraction comes second. So we could deal from the outside in, if you want to see it that way, where we want to get rid of stuff and really drill down on the main thing that we're looking to find, in this case the t, by first getting rid of any other terms that don't have t's in them, then looking at the terms with t's and dividing by anything that they're being multiplied by. So in this case, this negative 16 was a term without any t in it. That's why we moved it first to become h plus 16, where it used to just be h. Now to get t alone, we're going to divide by what it's being multiplied by. It's being multiplied by v, so we're going to divide each side by v. That leaves me with just t equals, on top, h plus 16, on bottom, v. Probably want to write it as parentheses h plus 16 divided by v. Problem 7 asks me to solve for t when I have p equals w divided by t. This is a little tricky because really when something's on the bottom that I'm trying to solve for, I'd rather bring it to the top. The way that I'm going to do that is I'm going to multiply both sides by t. When I do that, this t being divided by and this t being multiplied by will go away. On the left side, I'll have tp. On the right side, I now just have w. If I want to solve for t, I look at where it is now. It's currently t times p. To get that t by itself, I'm going to need to divide by what it's being multiplied by, which is p. That's how I wind up with t equals w divided by p. You'll notice that where we started here, p equals w over t. What really happened for our final answer was this t and this p just switch places by multiplying both sides by t and then dividing by p. Really, things of this format are going to work like that, where your variable, if you want to solve it, is on bottom of something, and another variable is solved on the left side. Really, they're just going to switch places when you do these operations. But ideally, you'd understand the operations as they go, and you'd understand that you're multiplying and then dividing to get to that final answer. In problem 8, we're trying to solve for v. V is currently being subtracted by u, but in parentheses, that whole thing is being divided by t. So again, we have to work from the outside in. Since this divided by t is happening outside the parentheses, I have to deal with it first. The way that I deal with division is I do the opposite operation, which is multiplication. I'm going to multiply both sides by t. On this side, dividing by t and multiplying by t are inverse operations, so they go away. On this side, a times t is going to give me at. It now equals what was in parentheses v minus u, but I can take out of parentheses v minus u because now that t has been dealt with, and basically these parentheses don't give me any additional information at this point. I can now get v alone by moving this u. It's currently a minus u. I move it by doing plus u to each side. When I do that, on this side I'm just left with a v. On this side I have at plus u. It's perfectly valid to write this instead as v equals u plus at. These are mathematically equivalent according to the associative property. It doesn't really matter which order you write these in based on addition, but you want to make it match whatever the answer choice is available. In problem 9, we're asked to solve for y when we have z equals 3x times y. In order to undo multiplication, we divide. So since it's being multiplied by 3x, we're going to divide each side by 3x. On this side, the 3 being multiplied and divided goes away, the x being multiplied and divided goes away, and I'm just left with this y. So I get y equals z on top being divided by 3x. In problem 10, we're trying to solve for v. It starts out as f minus e plus v equals 2. This v is really its own term. Nothing's being multiplied by it or divided. There's no parentheses around it, so I just need to move these two things that are kind of independent. This f doesn't have a sign in front of it, which means it's understood positive. To get rid of a positive f, we're going to subtract f from each side. This e has a negative sign in front of it. To get rid of a negative e, we're going to add e to each side. Plus e plus e. On this side, those go away, and just leave me with v. On this side, 2 minus f plus e has no like terms, so I would just write it as 2 minus f plus e. For a lot of these problems, it's going to be about recognizing which problem type it is, trying to rearrange based on seeing whether multiplication, division, subtraction, addition are happening. The more work you can get with these, the more it's going to help for all your science classes. There's going to be a lot of times where you're working with these variables and needing to manipulate equations. So I know you're used to seeing x and y, but in this particular section, I tried to use more sciencey equations and ones that are more like what you would see as you move along on your college education. So I understand if you hate all these variables being thrown at you, wish it was all just numbers, maybe an x or y, but it's pretty important as you move through biology, chemistry, other classes like this, that you're able to work with variables.